So today I'm going to be reading from this book by Mary Yule called Thinking Like a Phage. And she has a section called Featured Phages uh, that on page 16. And what I'm going to do is read the first half of the first paragraph of that section. So she writes, we know nothing at all about most phages. Globally, we've sampled a very small fraction of their total diversity. And it used to be that we would sample this diversity by actually culturing the phages and studying their phenotypic characteristics, things like their absorption rate and burst size and latent period, which is how long they infect, but also their biochemical and genetic characteristics. Today, however, we do things slightly differently, which he gets to. Many are known only from a bit of genomic sequence recovered from a random sample of DNA from natural communities. And this has been something that people have been doing for the past 10 plus years. And this involves taking samples of communities and isolating the DNA from those communities. A community being, by the way, a collection of species, different species that are found within a given environment. And what they do is they isolate and purify the DNA and then they sequence that DNA. Now, there's a lot of DNA there, and they can't sequence all of it because that costs a fortune. And so they only can sequence a sample of it. But the more of that DNA that they sequence, the more deeply they sample that DNA, and the more able they are to observe rare sequences in that DNA. So the rarer a phage is, if you are sampling just the viruses from an environment, the less likely it is that it's going to be sequenced when you're doing one of these metagenomes or viromes as they're known, unless you do a lot of sequencing. So the more sequencing you do, the more phage types you're going to observe. The more types of environments, the more phage types you're going to observe. Or the more often you sample a given environment, the more phage types you're going to observe. And people have been doing this for a while. We've got a fair number of metagenomes out there, but they're only so much that people can do per unit time of their careers. And as a consequence, there's still a whole lot of environments out there that haven't been sequenced deeply, and so there's a lot of phages out there that we still don't know about. Far fewer have been cultured along with their host in the lab. And this is in part because the bacterial hosts themselves often are very difficult to culture. The majority of bacteria we have a lot of difficulty culturing. And if you can't culture the bacterium, then you can't culture the phage because the phage is dependent upon the bacterium in order to replicate. We've had fewer that have had their genome sequenced or have, as she puts it, their their infection tactics observed. Approximately 6,300 have been examined by EM. EM stands for electron micrograph as of 2013. It should be pointed out that I believe that a lot of people, when they make that statement that there are, in this case, 6,300 phages known, they don't necessarily appreciate that it's actually known and also have had their picture taken using an electron microscope. There is a website, Bacteriophage Names 2000, that was put together by Hans Ackerman with my help, that at that time had about 5,000 phage names, which was impressive. But all of those phages were phages that were observed by electron microscope. Hans Ackerman was an electron microscopist. This is what he was into. And this is why these phages, in fact, this list is in fact of phages that are seen by EM. Hans unfortunately died a couple months back in the middle of the winter of 2017. By early 2016, 2,792 bacterial phage genomes and 67 archaeal viruses genomes had been sequenced. Mary actually says archaeal phage, and I want to encourage people not to use the phrase archaeal phage. A phage is something that infects bacteria, a bacteriophage, and we shouldn't be using the word phage to describe archaeal viruses. But be that as it may, this number is growing and growing and growing. We have programs in colleges where undergraduates, in fact, isolate and sequence and then name phages. And in the course of this, we're developing a huge number of phage sequences. The majority of these are sequences to the bacterium Mycobacterium smegmatis, which is a soil bacterium related to Mycobacterium tuberculosis. And the program that is involved in sequencing these Mycobacterium smegmatis phages, we can thank Graham Hatfull of University of Pittsburgh, which is just down the road from me at The Ohio State University, for setting up that program. Even the best studied, the subjects of thousands of published research papers each, still harbor unpredictable surprises. Although the unknown territory is vast, what is known could fill volumes. And in fact, there is a website that has those volumes. It's called Phage Monographs, and it's found in Wikipedia. So go to Wikipedia and type in Phage Monographs, or just go to Google and type in Phage Monographs, and you should be able to find this. Over the past 100 or so years, I think starting in 1921 is when the first phage monograph was published, we've had over 100 phage monographs published. So there is a lot of information out there just in books or edited volumes that cover phages. And then for a while there, we had a journal called Bacteriophage that covered nothing but phages. And there's lots of other journals out there, lots of volumes out there that are filled with phage articles. And there will be many, many more as time goes on. So I'm Steve Abaddon. I'm sitting here in the middle of Dry Creek. It is really, really cold out. I got up at 4 a.m. this morning to come out on this hike. And apparently that was way before the sun came up and it suddenly started getting warm. Next week, it's going to get up to supposedly 106 degrees here in Sedona, Arizona. This is the middle of June. But right now, if it's 50 degrees, I'd be surprised, and I am freezing my butt off. Otherwise, I hope you all have a wonderful day. I'm going to try to get into the sun and warm myself up. Have a great one. Bye-bye.